Welcome students to yet another live session on our course for hydraulic engineering. So, the topics that were more or less covered after live session were laminar and turbulent fluid flow, boundary layer analysis, open channel flow and dimensional analysis. However, you can ask any questions that you have, although it is even from the first part of the course. So, I am looking forward to some interesting questions. However, we floated an Excel sheet when this live session was declared, and based on that we have received 4 questions. I will go through them one by one. So, first question was asked by Mr. Anish Jangir, and his question was just simple 2 words: on assignment. So, my response to Anish is going to be it would be very nice if you can be a little bit specific. We also looked at your doubts that you have asked in the forum, and I think we have duly answered all your queries when it came to the assignments. So, Anish, if you have further questions, you can this is the time to ask. All right. So, the second question was by Mr. Balu Rathod, and his question was just stating about hydraulic jump. Although its specific question is not asked again here, but I would like to say what a hydraulic jump is. Hydraulic jump is a rapidly varied flow. So, rapidly varied means dy by dx is approximately equal to 1, which means that the water level with respect to the x distance changes very rapidly at a higher at a very large rate. So, again going to the definition. So, hydraulic jump is a rapidly varied flow where a supercritical stream meets a subcritical stream within a short reach. So, there is a head loss associated with this hydraulic jump, that is why it is analyzed using the conservation of momentum. In the lectures we have derived the entire energy loss and also those y2 and y1, the depth upstream and the depth downstream, both are related. And yeah, I think if you have more specific question, you can actually ask right now. So, the question number 3 was by Aditya Deshpande, and the question is how a partially full pipe flow is treated as an open channel flow. Okay. So, by definition, any flow with a free surface where the free surface is subject to a constant pressure in an open channel is an actually called open channel flow. So, in most of the cases this constant pressure at the free surface is atmospheric pressure. The fourth question was by Mr. Sanjay Korse, and the question was regarding the updated marks of assignment. Actually, we have already made an announcement regarding the same, regarding the re-evaluation of this assignment 2. On 20th February we have made that on the page. All right. So, we have another question by Love Kush. Love Kush, I think I am not sure, but if you are the same Love Kush that I teach in my regular hydraulics class, I have a student named Love Kush as well, and I taught this in my offline class hydraulic engineering at IIT Kharagpur 2 days ago. The question is an interesting one. The question is I am not understand. Okay, so it should be I do not understand the concept of y sub and y super in the specific energy curve. So, specific energy curve, you know, when we draw the specific energy curve, what is that curve? That is very much important. So, you know, when we plot y specific energy against y for a specific q and specific energy E, we get 3 y's. I will take the help of whiteboard. Okay. So, we get 3 depths, out of which one depth is negative. And why do we get 3 depths? Because the equation is third order or cubic equation in y. All right. So, for specific q e y1, y2, y3. So, one of the y is negative, which we neglect because it does not have any physical significance. Then there are 2 other y's, y1 and y2. Now, the question is, we call one as sub, let us say we call y1 as y sub and y2 as y sub. Sub means subcritical, y means supercritical, because as you see in the curve between E and y, if you see, yeah. So, if there is a curve here, you see this is E minimum, all right, this is the minimum energy, and the depth corresponding to the this is called y critical, and for any E you see it intersects at 2 points, this is y1 and y2. Now, which one to call y sub and which one to call y sup? Okay. So, y sub is greater than y c. You see this y1 is, this y2 is y sub, and this y1 is y supercritical. The reason is, it's, I mean, analogically if you see, this Fr is V by under root Gy. So, if y is going to be less, the Froude number will be larger, hence the depth which has lower corresponds to the Froude number, because this will correspond to Froude number equal to 1. The one below will be greater than 1, and the one here it will correspond to Froude number less than 1. So, I think I have clarified enough this concept about specific energy. Now, we can go back, new page, yes, now we turn off. So, I think Lavkush, I think this was your question itself. I think if you have further doubt you can ask, but the main concept here is that Froude number is V by under root Gy. If y is going to be less, the flow is going to be supercritical, and Yc, where the energy is minimum, corresponds to the critical flow where Froude number is equal to 1. If you have further, please let me know. Open to some other questions. So, we have answered 6 questions till now. So, these lectures I think are being recorded, it will also be put as a lecture, I think on YouTube, which you can see later as well. Are there further questions? I am unable to. Okay, Lavkush has another question saying that I am not understand, you do not understand the concept of equation q square g by at cube. Okay. So, I will use the okay. So, you know the specific energy E is given as y plus v square by 2g, or E is given as y plus q square 2g a square. So, for E to be minimum, which is I criteria for obtaining critical depth for a given q, you put dE by dy is equal to 0 for minimum, and therefore, when you do that, you will obtain q square t by g a cube is equal to 1, where t is the top width. Okay. Okay. So, I think this shall answer your question, and now we can go to all right. Is there any other question? Not yet. Okay, so I think Aditya Deshpande, you have already asked this question, so I will repeat again. So, how a pipe running partially full treated as an open channel flow? So, by definition, open channel flow is a flow which has a free surface and exposed to a constant pressure. All right. So, at any point on the surface, the pressure remains same. In most of the cases, it is exposed to atmosphere, hence the pressure is atmospheric. I will just maybe to clarify, I will what I am going to do is, see, let me draw a pipe here, all right, and let us say the water is filled like this. So, this is water, and what is here? Air. Air, this is natural air, right? Atmosphere. So, what is the pressure at point 1? Pressure at point 2, pressure at point 3, pressure at point 4, you tell yourself. It is going to be atmospheric pressure, right? Although this water is in the pipe, but the free surface here, water is filled up to this point. This is exposed to atmospheric pressure. So, pressure does not change at anywhere in the surface, whereas in traditional pipe flow, what happens is, this is completely filled with water, all right, and here is P1 and here is P2, where P1 is not equal to P2. Therefore, in pipe flow there is a pressure gradient. Okay, so, if this is x, that means dP dx is not equal to 0. Here in open channel flow, dP dx is going to be 0 or may not be 0 also, both can be there, alright. So, anything by definition, any flow whose free surface is exposed to a pressure, a constant pressure, in most of the cases atmospheric pressure, is treated as open channel flow. Great. So, Aditya, I think this should have clarified your doubt. Do we have further questions? Hmm. So, we have a question from Aditya D. Aditya Deshpande. The question is, why, sir, why is the length of diverging section more in case of Venturi meter And the answer to this is because it controls the disturbance in flow due to vena contracta and gives sufficient time for flow to stabilize. All right. And Lavkush, it's Lavkush, right? Lavkush, are you student of IIT Kharagpur? You can let me know. Please describe the concept of E min, or so as a minimum specific energy in a triangular section for uniform flow. See, Lavkush, the concept of E minimum remains the same. All right. So, for a triangular section the area will change, that is it. You know, the hydraulic radius or the area or the wetted parameter, those remains the same. There is no different concept. The constant of E minimum is the same. At E minimum you will always obtain the critical depth. So, yeah, to make it a little interactive, the formula remains the same, q square T by G A cube is equal to 1. Okay. So, you can put A and T for triangle. Normally, if you have trouble finding what is T, what is A, you remember how we derived this uniform flow. You remember? So, repeat the same procedure, that is use momentum and continuity equation. If either of the two approaches will give you correct answer, either this one or this one. So, there is no difference at all. All right, just the cross section changes does not mean the concept will change. Yes, in triangular section E minimum is 1.75 YC, and in the class we obtained for a rectangular section 1.5 YC, which is fine. You can try to derive it yourself. Actually, I have probably I have a question in my slides, this NPTEL slides that you are doing, where we did it for a triangular section. If you go through it, you can see how we have done. So, how many students are there in the room? Guys, if you have further question, I think it is the right time to ask. Otherwise, we have our last session next month, or you can always ask these questions in the forum, where I think the teaching assistant promptly replies to you. Okay, Lavkush has asked another question. I do not understand the concept of maximum discharge required minimum weighted parameter. I think you want to say that you do not understand this concept, that why maximum discharge requirement is the presence of minimum weighted parameter. Okay. So, we will go now and see, you see Q in terms of Chazy's equation, all right, this is the one, S is the slope, all right, and hydraulic radius is A by P. So, if you see for a given area and slope, Q is maximum when P is minimum, because P is in denominator of the equation. It is quite simple, all right. I think if this is as clear as it can get. So, Lavkush, I hope you have answered your question. I will just say, I think most of you have asked what you wanted to. If you have something else, you can talk, otherwise we will start wrapping up the question answer session. Just in case if something comes in your mind that you wanted to ask today and could not, better post it in the forum. Okay, you will receive a prompt reply. I think the same day your reply gets answered. So, as far as I am concerned, I will see you live again in the last session next month, and I wish you all good preparation for your exams. Do take the exam, because you will get the certificate, and this is one of the most basic course if you want to stay in this field of hydraulics and water resource. So, that needs a great understanding. Okay, thank you so much, and I will see you next month. Have a great evening.